Welcome to Unit 6, Lesson 6, Exponential Growth Functions. So before we get into the exponential growth functions, I have a question for you. Would you rather work and be paid $100 each day for 30 days, or a penny the first day that doubles every day for 30 days? So you get paid a penny the first day, 2 the second, then 4 the third, like that. So I want you now to pause the video and in your group discuss and decide who wants to do which choice, either $100 each day or a penny that doubles every day after that. So go ahead, pause the video now and discuss. Okay, we will revisit this later. So exponential growth. For exponential growth we'll see written two different ways. We'll see it as y equals c times 1 plus r to the t, and this happens when our r equals a percent. So if you see in the problem you increase by a certain percent, then we know to use the first equation. And c equals the initial amount we start out with, and t equals the duration of time. Our second equation is y equals c times r to the t. And this is when r equals just a flat rate, like something doubles, something triples, something halves. That'd be a flat rate. C is still the initial amount and t equals time. Now these exponential growth functions are talking about things that are growing, and they're growing exponentially, meaning that they are getting very big very quickly. Just like our graphs that we did yesterday. Some of those graphs got very big very quickly. So these problems are going to be, for the most part, word problems, and they're going to have us use our problem solving skills. So here's our first example. See, it says you deposit $500 in an account that pays 8% interest compounded yearly. What will the account balance be after 6 years? Now this is a very common problem that's used, and this is something similar to what they do in banking. You'll see exponential growth used in banking stuff, finances in general. You'll see it with a lot with population growth as well, of people, of animals, like that. So we have to recognize our different things. So we have the different pieces from these two equations. First off, we need to recognize which one of these equations are we going to use. Is r equal a percent, or is it equal a rate? Well, if we look, it says that it pays 8% interest. So that's a giveaway that we're going to be using the first one. So we know we're going to use y equals c times 1 plus r to the t. Now we have to figure out what c is, what r is, and what t is. C is our initial amount. So how much did we put into the account at the beginning? It looks like $500. So we first put in $500. Our rate, we said, was at 8%. And whenever we write out what our r equals, if you look here, this is 1 plus r. So we can't put percent. We have to change that r to a decimal. So 8% equals 0.08. And then our t is the amount of time. And that also depends on how our interest is compounded. So it says our interest is compounded yearly. So every year it adds up. And we want to find out how much there is after 6 years. So our t is going to be 6. Because it's happening every year and we spend 6 years, we're only going to do it 6 times. So now we can plug this in. So y equals 500 times 1 plus 0.08 to the 6th. And we can simplify this further by adding the 1 plus 0.08. And from here, we just need to plug it in a calculator and see what results we get. And after we plug that in a calculator, we get $793.44. And units are very key here. We have to be thinking about units the entire time. because this is money, we know that we're going to round it to the hundredths place. But what happens if it was a person, if we were counting people, if we were counting animals? Are we going to say, well, we're going to have 5.32 rabbits? That doesn't really make sense. If we're going to be talking about people or something living, we want to round it to the nearest whole number. But because it's money here, we're going to round to the hundredths place. So this requires you to think outside of what's being presented. Think about how we're using these things. So our second example, we're going to talk about mice. So we say an initial population of 20 mice triples each year for 5 years. What is the population after 5 years? Well, the first thing we always want to establish is which exponential growth function are we going to use. And I do not see a percent here, and I see this word here. Triples. That tells me it's a flat rate that's happening every single year. So that means we're going to have to use y equals c times r to the t. Now we need to figure out what our c, r, and t are. So c is our initial amount. So how many mice were there at the beginning? Looks like there were 20. Our rate is tripling, which is 3. And the time, it says population after 5 years. So it looks like t equals 5. So we say y equals 20 times 3 to the t, not t, to the 5th. We plug that in our calculator and we get 4,860 mice. And wow, that is a lot of mice after just 5 years. We started out with 20 and we got a lot. Okay, so here I have an example for you to try about rabbit population. So go ahead and in your group, I want you to pause the video and try this problem. Now, please. Alright, and here is the solution to that. So, I want you to go ahead and pause the video and review this with your group now. Okay, I have another example for you. Zombies! The outbreak has occurred. One zombie started in a town of 50,000 people. If each zombie feeds on one person a day, how long until all people are zombies? So I want you to go ahead, pause the video, and try this with your group. Now, as I'm sure you found out, this is a bit different than the ones we've been doing. Before, we asked to find the result. We were asking to find what y equals. Now we're asking to find out t. We're wanting to find out time. And that's a bit different. Now, because we're not going to go into a certain part of exponential functions that would make solving this more mathematical, we're just going to try guess and check kind of work. So we want to know something that will make this true. Now, another thing you had to notice was, what was the rate? Well, r equals 2, because if you think about it, if each zombie bites one person a day, if we start out with 1, they bite one person, we get 2. Those 2 bite 2 people, we get 4. Those 4 bite, they get 8. So it's doubling every day. So we wind up with this equation here. So we want to find out a t, how many days will it be until all 50,000 people are zombies. So what we need to do is we need to plug in numbers for t. We just need to guess and check kind of, but use our intuition to think, because we don't want to say guess 2 days, because we know 2 days obviously is not going to work. 4 days probably isn't either. So we need to think bigger. So let's try it with t equal to 10. So we're going to do 1 times 2 to the 10th. See where that gets us. And we see that we get 1024, which is still nowhere near where we need to be. So let's try something a bit bigger. Let's try t to the 20th. So we try that, and we get we get 1,004,8,576. So 2 to the 20th probably is a bit too big. So what that tells us now is that the next thing we need to try is something smaller. Well, let's try t to the 15th. Let's try in the middle. So we try 1 times 2 to the 15th, and we get 32,768. That's really close. So let's try t to the 16th and see if that gets us there. And we know it should, because whenever this 32,000 doubles, we will definitely be over. So 2 to the 16th gives us 65,536. So it looks like 16 days would be our answer. But unfortunately, on that 16th day, some of the zombies are going to be hungry, because not all 32,000 of them will get to eat. So that's how that you would solve problems like this. Sometimes you need to guess and check. Sometimes there's problems for our exponential growth that are cut and dry, and we can plug some numbers in and figure them out. Now I want to take you all the way back to the first question that I asked. Would you rather work and be paid $100 each day for 30 days, or a penny the first day that doubles every day for 30 days? So what I want you to do now is use your knowledge for exponential growth and figure out which one is the better choice. So go ahead with your group, pause and do that now, and after you work that out, that'll be the end of the video.